In the words of Arthur C. Clarke, two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. We can come to the conclusion that the laws of nature, of physics, the laws of the universe, are fine-tuned to create life, since we exist. The universe may indeed be teeming with life. If that is the case, why have we not succeeded in communicating with other intelligent life? First, there is the time factor. For basic cellular life to appear on a planet takes an extraordinary amount of time, even more so for intelligent life to evolve. Then there is the distance factor. Even a radio wave traveling at the speed of light can take millions or even billions of years before it can reach another civilization elsewhere in the universe. Therefore, when we combine the time required and the extraordinary distances involved, it is not surprising that we have not succeeded in receiving a message from anywhere or anyone in the universe. We must also not lose sight of the fact that we, intelligent humans, are very much new arrivals. On the cosmic calendar scale, we just popped into existence about 1 minute ago. Another possibility is that intelligent civilizations possibly self-destruct before they succeed in communicating with each other. Maybe human intelligence is overrated. The prevailing consensus is that there was a beginning of the universe, a moment of creation, the Big Bang. Observational evidence provided by the red shifts of galaxies and the cosmic background radiation support the inflationary model along with the accelerating expansion of our known universe. Because the Big Bang theory is related to the origin of the universe, it has become a polarizing subject between religion, philosophy, and science. The Big Bang theory does not indicate how energy, space, and time emerged. We should be cautious of statements indicating that the universe, the Big Bang, created itself out of nothing. The idea that random energy and matter spontaneously converged and sparked the Big Bang appears illogical. We can ask, where did the random energy come from? The simple truth is that we don't know. It cannot be proved, and it cannot be disproved. What we do know is that here on Earth we have what is possibly the most complex and extraordinary process of the universe, the emergence of life. Earth may not be the only place where this end product, the emergence of life, exists, but we know that it exists since we are witnessing it here and now. Einstein's general relativity has shown us that gravity is simply mass bending, warping the fabric of space. It has also taught us that space itself is like a fabric, that it is bendable, that it is influenced by the mass of objects. Gravity is an enigma, almost paradoxical in the sense that it is the weakest of the four forces of electromagnetism and the weak and strong nuclear forces. Gravity is weak enough to allow you to pick up a rock from the ground with the entire Earth's gravity pulling on it. Its range is simply unlimited. Its force knows no boundaries as far as distance is concerned. Gravity, in fact, may be the most important, the most fundamental force of the cosmos, because gravity is the grand sculpture, the builder of the universe. It is gravity that is responsible for the creation of galaxies. It is gravity that causes a star to go supernova, from which the dust remnants, again propelled by gravity, conglomerate to create new stars, new planets, and eventually us, humans. Gravity is the grand architect, the master builder of the universe. Gravity is also paradoxical in the sense that it appears to be the only missing link to a grand unified theory that would combine general relativity and quantum mechanics, which have eluded scientists in the last decades. We cannot disassociate time from space, hence the term space-time. Time is interwoven into the very fabric of space. The way we measure time is also directly related to space. For example, we have 24 hours, the time it takes for the Earth to do a rotation on itself, on its axis. We measure the months by roughly the time it takes for the Moon to go around the Earth. We measure a year based on the time it takes for the Earth to do a revolution around the Sun, a total orbit around the Sun. What do we know about time? We know, for example, that time appears to flow like a river, flow in one direction, that it goes from past, present, to future. Einstein's special and general relativity has taught us a few things about time. First, there is the premise that there is no distinction between past, present, and future, that it all exists as one entity, all at once, the same as, for example, the North Pole, the equator, and the South Pole. Then, there is the fact that time is affected by gravity. Time flows more slowly on the surface of the Earth, on the ground, than for someone who is on top of a mountain, for example. This, in fact, has been proven by using very precise atomic clocks. It is also a fact that time passes more slowly for a person who is moving than for one who is not. That the faster that you move, the more slowly the time passes. We perceive time as having the direction of going from past, present to future. For example, we can drop an egg on the floor, we will see the egg leave our hand, we will see the egg shell break as it hits the floor and the egg splatter. However, there is nothing in the laws of physics that prohibits the reverse from happening, from the splattered egg on the floor to reassemble itself, to get inside the shell, and to rise up again back into your hand. This means that time travel may indeed be possible. We just currently do not know how to do it. Just because we do not know how to do something does not mean that it is impossible. What is the ultimate destiny of the universe? Will it go on expanding forever? Or will maybe gravity eventually draw everything back into a big crunch. With the accelerating expansion of the universe, it is suggested that maybe the universe will go on expanding forever. These are questions that are almost impossible to answer. We should admit that we simply do not know. For example, we don't know where we are located in the universe. Are we at the center? Are we near its edge? We don't even know if the universe has an edge. There may be other dimensions to the universe that we simply do not understand. It is Albane who said, "The universe is not only stranger than we suppose, but stranger than we can suppose." What we do know is that the laws of nature, the laws of physics, are indeed fine-tuned to create life. Since we exist, perhaps it is the purpose of the universe to become self-aware.